evening, everyone. Jason Houtman here, and this is data on minerals that students will be working with. I apologize for my late submission. I broke my wrist, and it made doing work very difficult. So anyway, students will have some samples of minerals. For example, biotite and calcite and feldspar, graphite and gypsum and halite and magnetite and muscovite, pyrite, quartz, and whatever samples we have available. And we're going to look at these samples and we're going to categorize them into colors, and then we're going to do some streak tests where we rub the mineral on a piece of tile, which is extremely hard, and then whatever streak it leaves is known as the streak. Whatever color it leaves is known as a streak. So you can see some leave white, some leave none, some leave mixed, some leave gray. And then we'll do a hardness scale, and the hardest thing on the surface of the planet is a diamond. So that's a 10, and then like a fingernail is like 2.5, and then so gypsum, we can cut it with our fingernail. Feldspar, you need something harder, like a 7 or 8 or a 9 or a 10 to cut that. And feldspar has iron in it. The Fe is the iron. And so calcite's 3, it's calcium, very soft bone material, over millions of years. Biotite soft, and this is right in the middle. Right, so then we have other concepts like cleavage. So how does it break? You hit it, how's it going to break? So it cleaves, breaks, and this is octahedral. So the crystal structure is octahedral. This one fractures. So, and then also specific gravity. So you put it in a pool, and pool of water, and you weigh it, and you weigh the water, and you weigh this, and you see how much water it displaces, and it gives you a density concept, medium, heavy, and so the harder ones are going to be heavier, so there's correlations there. And then as a metallic, obviously metal, very dense, so you can see that, you see correlations right across the board. Like, let's zoom in here, so like we could, for example, light one, graphite, right, so pencil, it's gray, it's very soft, you could break it easily, you could scratch it with your fingernail, it cleaves, it's light, it's metallic color, it's dull. And here calcite, it's organic, so it reacts to acid. Just quick references, let me go up to the top, right, other properties, so it's flexible. The biotite, like, you go to a rock and you see the little shiny biotite, black mica, and it's flexible, and you can play with it, and you can do things with it, and that's soft, it's 3. And then you can go down here, and you look at the heavy ones, and, they're metallic, they're rusty, they're metallic, they're heavy, they fracture, you can crack them, they're red and brown, hematite, nice shiny, you get the rock hits, and they're always in there, and the shiny, people use them ornamental, pretty cool stuff. I've always liked hematite. Muscovite is also, it's glassy, so it's soft. And then quartz, it's very hard. Quartz is very hard. It's a very hard crystal. And so, that's a way to gather information, gather data, look at it, compare it, understand how the minerals are, what they look like, so you're able to see them, and then organize them in the Excel, and it makes life a little bit more interesting for everybody, and it's another way to look at data and to organize it, because to have all these random facts all over the place is a lot to manage and deal with. So if you could lay it all out on paper, it's just another way to help your brain organize the data put forth. So again, I apologize for the late submission, and I hope you enjoy enjoyed my video, and I know I